In 1981, the personal computer industry was accelerating rapidly. Apple had its Apple II, a colorful and approachable machine that was winning over homes and schools alike. Commodore offered budget-friendly systems like the VIC-20, appealing to hobbyists and casual users. Meanwhile, Tandy's TRS-80 had already established itself as one of the first widely available personal computers in retail stores. Against this vibrant backdrop, IBM, the undisputed leader in corporate mainframes, suddenly found itself at risk of falling behind. IBM's machines dominated banks, corporations, and government institutions, but the company's culture was built around large, expensive systems with slow, methodical development cycles. The emerging personal computer market demanded the exact opposite: speed, affordability, and accessibility. Many inside IBM feared the company's bureaucracy and rigid structure would prevent it from competing effectively. A bold decision was made: rather than building a personal computer the traditional IBM way, they would break the rules and try something entirely new. This initiative was codenamed Chess. A small team of just 12 engineers, led by Don Estridge, was assembled in Boca Raton, Florida. They were given an unusual level of freedom, allowed to bypass IBM's normal procedures and focus entirely on speed, practicality, and results. Within a single year, they designed, built, and launched the IBM personal computer, Model 5150. For IBM, a development cycle this fast was unprecedented and became one of the core reasons for the project's success. The philosophy behind the IBM PC marked a sharp departure from IBM's past. Historically, IBM insisted on designing and manufacturing proprietary hardware entirely in-house. Estridge's team knew that approach would be too slow and costly. Instead, they embraced an open architecture, selecting components already available on the market from multiple suppliers. At the heart of the system was the Intel 8088 processor. Internally a 16-bit CPU capable of advanced instructions, it communicated externally via an 8-bit bus. This clever compromise made the processor more affordable and compatible with a broad range of existing support chips. While not the fastest option available at the time, it struck the perfect balance between performance, cost, and availability, making the IBM PC both accessible and easy to replicate. The effects of this open approach were profound. Other companies quickly realized they could build IBM-compatible machines by following the same design. The BIOS, stored in ROM, standardized how software interacted with the hardware. Once other manufacturers replicated the BIOS, clone PCs flooded the market, creating competition that lowered prices and expanded access to personal computing. Physically, the IBM PC mirrored this philosophy of openness and flexibility. Its steel chassis was solid but modular, allowing users to upgrade components easily. Expansion slots enabled additional memory, peripheral cards, or new functionality. The system could accommodate 1 or 2 floppy drives, and later, hard drives. This modularity reassured users that their investment would last. They could upgrade instead of replacing the entire machine. Software was just as forward-thinking. The IBM PC included IBM Cassette Basic and ROM, allowing users to start programming immediately, even without a disk drive. For many, this marked their first exposure to coding. The real game-changer, however, was the operating system. IBM partnered with a young Microsoft to deliver PC-DOS 1.0. Microsoft's licensing strategy allowed them to sell essentially the same system as MS-DOS to other manufacturers, a move that positioned the company as a software powerhouse for decades to come. The IBM PC was also compatible with CP/M, the leading operating system of the late 1970s. This reassured businesses that their existing software investments were safe. Developers quickly saw that writing software for the IBM PC meant reaching a growing audience, including both IBM users and clone owners. In no time, the platform became the preferred choice for software development. From a design and user experience perspective, the IBM PC may seem basic today. It had no graphical interface, only a command line. Yet every detail was carefully considered. The keyboard became legendary for its tactile feedback, precision, and durability. Professionals often regarded it as the best keyboard ever made, and even today, enthusiasts hunt for vintage IBM keyboards. Documentation was another vital aspect of user experience. Unlike competitors, IBM shipped detailed technical manuals, which not only explained how to operate the machine but encouraged users to develop their own software and hardware. By providing transparency, IBM cultivated a community of innovators, accelerating the growth of the IBM PC ecosystem. Every component reflected thoughtful design. The Intel 8088 processor delivered enough power for spreadsheets, word processing, and other business applications. The ROM BIOS simplified programming, ensuring software behaved consistently across machines. The 5¼ floppy drive became a standard medium for software distribution. The IBM 5151 monochrome monitor, while limited to green text, provided sharp readability, ideal for productivity. The IBM PC's strength lay in pragmatism, nothing flashy, everything functional, and reliably integrated. The team behind the IBM PC deserves recognition. Don Estridge's leadership fostered pragmatism and openness. Engineers collaborated with Intel, Microsoft, and Seagate, allowing external expertise to flow into the project. For a company like IBM, this level of collaboration was revolutionary, yet visionary. The IBM PC's impact went far beyond hardware and software. By establishing a standard, IBM legitimized personal computing for businesses, schools, and governments. Suddenly, a personal computer was no longer a hobbyist's toy, it was a professional tool. This credibility accelerated adoption worldwide. The proliferation of clones amplified the effect. Competition drove prices down, developers had access to a massive audience, and software flourished across business, education, and entertainment. Within a few years, the IBM PC and its compatibles dominated the market, shaping the trajectory of the industry. The lessons of the IBM PC remain relevant today. Openness often outweighs control. Collaboration can outperform isolation. User experience is more than visuals, it is reliability, expandability, and trust. Even with a command line and a monochrome screen, the IBM PC offered a professional, dependable experience. Culturally, it changed perceptions. Personal computers were legitimized, creating the conditions for Microsoft's rise and establishing a standard for hardware and software that endured for decades. Its influence reached education, business, and entertainment, shaping how people interacted with technology worldwide. More than 40 years later, the IBM PC's DNA is everywhere. Its open architecture inspired generations of engineers. Its modularity and compatibility continue to define computing platforms. Every modern desktop, laptop, and even smartphone owes a debt to the decisions made in Boca Raton in 1981. The IBM PC 5150